we'll go back and solve for the we'll take this this function right here. So this was the function, right? And we needed a line that's parallel to this line, and by parallel then we know the slopes have to be the same, and right here then we have this like this little mathematical expression. We have like almost like a it's almost like a function, if you will. You could it's actually a transform. Like we're going to be changing this function. We're going to be making we'll be making a new function really that describes the slope of this function for every single x. So when we have a function then that describes the slope of this at every single x, then we can be like, okay, so once we know the slope, then all that's left then is to figure out, is to solve for x, right? Because if this describes the slope for every single x, and we need to find a slope that's equal to well, the slope of this one is clearly -2, then we just need to find an x then. So we need to find an x for this function that such that this function will generate a -2. So we want to basically set this f prime of x equal to -2, because, and then solve for the x, and solve for x, because we're thinking, we're like, okay, so we have this function that describes all the slopes. And so if we have this function that describes like all the slopes, so we almost think of like this guy, and we'll put on the y-axis all the slopes, and so that would be like the f prime of x, and this is also going to be our y-axis. The y-axis is going to be all of our slopes, and so this is just like our f prime function. And so, like, just as we've written prior, then we know it goes like this. And we can just see, just graphically, we need this f prime to equal -2. So we kind of put in we could almost put in a function here at -2, just a line, and we'd be like, okay, so it equals at this point. So then what's the x that corresponds to that point right there? And then we just simply solve for that x. And that's really what you see is going on right here. And so so now let's try applying this definition. And I definitely wouldn't suggest applying this definition except for these simple polynomial cases. There's better rules and other kinds of things that you can memorize that'll make things much faster than using this definition. But the definition is important. So, and since that's what we've defined already, we'll use it. And so first off, we have f of x equals x squared minus 7. And over here we have that we're doing f of delta x plus x. So since we have this f of let me write it up here, f of delta x plus x, we'll write in this limit delta x approaches 0. F of delta x plus x minus f of x all on top of delta x. And so this equals, so we'll just take this expression and plug that guy into there, which then gets plugged right into there. So that means we then have this, so like these two expressions are equivalent, and these two expressions, are like equivalent, and these two are equivalent. So transitive property of equality, I guess you could say. So that means we'll just put in this delta x plus x squared minus 7. And so that's this chunk right there. That's this chunk right there. And then we want to subtract off of it. And sorry, I'd like to keep this all. Let's actually, I'll move this one down. So don't worry about that one right there. We'll do the same thing right here. Delta x plus x squared minus 7. And so that's just this part right here. And then we have minus f of x, and f of x, that one's really easy. It's just x squared minus 7, and then on top of, well, our definition just simply has this delta x. So we have this delta x. Take the limit as delta x approaches 0. So then all we have to do really, kind of the big thing that we have to do is we have to square this expression, right? This delta x So like this delta x plus x squared, we want to break that one apart, so it's simply delta x, so we'll just multiply this guy out, delta x plus x, delta x plus x, and we'll just say, okay, so we have delta x squared plus delta x times x, we have delta x times x. Notice that delta x and x are two different things, so it's not like they combine. And then we have plus x squared, but that's kind of obvious, because it just follows the form of a plus b squared. So it's just like the a plus b, etc. But we're just doing that by hand. This time delta x squared plus delta x times x plus x squared. So so then what we'll do is we'll just be like, okay, so we have this expression right there, and so we're just going to replace, and this expression equals our delta x equals this expression right up here, so we'll just replace it. So that means we have this delta x squared plus delta x times x, or 2, sorry, I missed it, 2 plus x squared minus x squared, or minus 7, sorry. Yeah, and this should actually be a plus 7 right here, because it's minus this f of x, so it's minus this entire quantity. So that means we have this minus x squared plus 7, or sorry, I'm making mistakes, sorry, minus 7, because that minus 7 comes right down from there. And then we just put in this expression minus x squared plus 7, all divided by delta x. It's the limit as delta x approaches 0. And so that's kind of messy, and so let me get a new sheet of paper and finish this guy up. So we'll just rewrite this guy out. So this is the limit as delta x approaches 0 of delta x squared plus 2 delta x times x plus x squared minus 7 minus x squared plus 7, all on top of delta x. So now we'll just look and we'll be like, okay, I see my 7's cancel, I see my x squareds cancel, and then I'm just left with this expression. So this all equals delta x squared plus times delta x times x on top of delta x, limit as delta x approaches 0. And I see that we can factor out this delta x, so we'll take the limit as delta x approaches 0 of, take this delta x out, we're just left with a delta x plus 2 times x, all on top of delta x. And so then I look and I'm like, hey, these two guys cancel, right? So that means we're just left with the limit as delta x approaches 0, and that's delta x plus 2x. And so just looking at this, as delta x approaches 0, then that's just going to be 0. So that means it's all going to come out to 2x. So this is then, it's going to be our f prime of x. There's just this 2x right there. So so that's pretty straightforward, I think. I think that's you might be wondering why I went through all that work to cancel out the delta x, why I didn't just replace it with 0 prior, and that's because if I replaced it with 0, so like our original expression was this this delta x plus x squared minus 7. That was like our f. This was our f of delta x plus x. And then we had that minus that f of x, which is minus this x squared minus 7, all on top of our delta x. And that was the limit as delta x approaches 0. And you might be wondering, like, why I didn't just replace, like, you look and you're like, I replaced my delta x with a 0 right here. Why didn't I do it here? And that's because we'd be getting this division over 0. We get this, like, 0 plus x squared. Or 0 plus x squared minus 7 minus this x squared minus 7, all on top of this 0 limit as well, we're saying this is these two expressions are equivalent, and you can kind of see that